Hey guys, this is just a little bit of background information or pre-information as we're getting into Trig, and in order to help you with Unit 4.2 that we are working on. The first thing is hopefully you read that sheet that I gave you on radians, and so you understand that radians are just another way to measure an angle. And it's dimensionless, so we can use it more often than we can use degrees. So I want to make sure you know how to convert degrees to radians and radians to degrees. It said so on that paper, but we did go over this in class. So convert degrees to radians. You simply take whatever degree you have. So let's say I know I've got an angle that's 100 degrees and I want to convert that to radians. So I take 100 and I multiply that by pi over 180. Now when I do that, I always want to leave it in terms of pi. So I'm simply going to leave that little pi there, and I'm going to just take my 100 and my 180 and simplify it. Because when I multiply this out, it ends up being 100 pi over 180. When I simplify 100 and 180, I get 5/9. So this is how we would write it, 5 pi over 9. Now understand, pi is a number, so if we needed to know decimal-wise about or approximately what that number is, we could multiply that out to get that number. But generally, you leave radians in terms of pi. Now, it doesn't always have to have a pi in it, and we don't have to label the radians. It is understood that it's in radians if there is not a label. Now, if there's the degree symbol, obviously it's degrees. If not, then we can assume it's radians. That's why labels are so important. Okay, so then the other direction, you've got to make sure you know how to convert radians to degrees. So we do that like so. So let's say I have pi over 7 radians. I want to convert that to degrees. So I take my pi over 7 and I multiply by 180 over pi. This is to ensure that those pi's cancel out, and then I have 180 over 7. If that could be reduced, I would reduce it. If I needed to know, about what that number is, I could divide it out, and I get something like this. But typically, I do want you to leave it in an improper fraction. Okay? Okay, so degrees to radians, radians to degrees is super important. You've already done the unit circle, and you have labeled both radians and degrees on your semester project. We're going to do more on the unit circle. You're about to do an exploration on that. You can refer to any resource in order to fill that out. But now you know how to convert. If you have all the degrees all the way around, you now can convert them to radians. Okay, so a little bit more about angles. I want you to take a look at if I've got an x and y axis, and then let's say I have the unit circle here. Okay, so I have a radius of 1. Sorry for that sloppiness. So that points at 0, 1. So this radius of the circle is 1, right? Okay, well, when we're talking about the unit circle or any angle on the unit circle, this side right here is the side we always start. This is called our initial side. Okay, that's the initial side. And every single angle, that is where you will start, our initial side. Okay, now if let's say I want to draw a 360 degree angle. Okay, well, this is my starting point, this initial side. So this, I would draw a line around and back here, and this is where I'm stopping. So I started here and I stopped here. That is a 360 degree angle. Direction is very, very important. Okay, now let's draw another angle. Let me switch colors. So let's say I wanted to draw an angle. I'm going to draw one over here. Okay, so here's my initial side, and this side is called, I'm going to draw an arrow. This is our terminal side, so it's where the angle ends. So this angle right here, I'm just going to say that's about 135 degrees. Okay, notice I start at my initial side. This is called my terminal side. The terminology is very important for you to understand. Okay, well, I can start at the same side right here, but I could also go this direction. And this is also an angle. However, this is a negative angle. The direction determines whether or not it's positive or negative. So when I start at the initial side and I go clockwise, I will always have a negative angle. If I go counterclockwise, it will always be a positive angle. So this like teal angle I just drew here, how do you think I'd figure out what the measure of that angle is? So hopefully you're thinking about a whole circle's 360 degrees, and then if I subtract that 135, so if I take 360 and subtract 135, that'll give me this remaining portion, which would be 225. Okay? Now, key is this angle, again, is a negative angle because of the direction. So that is a negative 225 degrees. Okay? Always starting from this side. Positive if you go counterclockwise. Negative if you go clockwise. Okay? Now, I drew these two angles specifically for a very good reason. So if I have angle 135 and this other angle, negative 225, both of these angles create what's called coterminal angles. And the reason they're called coterminal angles is because they have the same initial side and the same terminal side. Okay, you're going to have to be able to do that and come up with coterminal angles for any given angle. I asked this question in class, do you think there are any more coterminal angles for that particular angle 135? Well, let me tell you there are, and here's why. I could start at the same initial side, and I could go around and come back to here. That angle that I just drew went all the way around 360 and then an additional 135 because coterminal angles have to start and end in the same place. So it doesn't tell me I have to go around a certain amount of times. So I would take 360 and add 135, and that gives me that angle I just drew is 495 degrees. That angle is also coterminal with angle 135 and with angle negative 225. So my question for you that I want you to think about is, how many coterminal angles do you think I could come up with? And hopefully you just thought infinite amount. Okay, so you have to be able to come up with coterminal angles, and as you can see, what I just did in order to be able to do that is added 360 degrees. So to find coterminal angles, all you do is add, or I could actually subtract 360 degrees in order to find a coterminal angle. So in the yellow there, I went counterclockwise in the positive direction. Well, I could do the same thing and go around once and then back around here, and I now have a negative coterminal angle, right? So I can add or subtract the 360 in order to determine coterminal angles, and I could go on and do that forever. I will say, as we get more into the unit circle, you have to be familiar with degrees and radians. So 360 degrees in terms of radians is 2 pi. So when we're in radians, you're adding or subtracting 2 pi, and when we're in degrees, you're adding and subtracting 360 degrees. Okay? Okay, now you should be able to do the exploration 4.2.1, which is on the unit circle. There's 2 questions on the back you need to make sure to answer. And then you can do the 4.2.1 angles and 4.2.2 evaluating trig expressions. You can give those a shot, and as you have questions, come see me. Hope to see you in class next time. Adios.